Okay, so we've got question 1 from the measuring rates of reaction questions. And in question 1, it's asking you that if we are measuring the rate of reaction, basically which type of measurements do we have to take in order to work out the rate of reaction? So what do you have to measure? What do you have to observe changing during a reaction? So if we start at the top one, we're measuring the mass. So obviously in some of the previous questions, we've seen that a gas is being given off. And so if a gas is being given off and is leaving the reaction vessel, then the mass is going to change. In those situations, it's probably going to go down. But it gives you a recordable value that you can measure. And so recording the mass allows you to eventually work out the rate of reaction. Likewise, in those situations, measuring the volume of gas directly will also allow you to do that if you collect it in a gas syringe or something similar. As we've seen again in some previous questions, the volume of solution is usually relatively not required for an experiment. It's usually concentration, amount of substance, number of moles, things like that, that affect a rate of reaction. The actual volume itself is usually fairly irrelevant, so that's not required. And in order to see frequency, we'd actually have to be able to see individual atoms and particles, so that's not going to happen either. So moving into question 2 then, a student has investigated a reaction and is attempting to vary the temperature for that reaction, and this one is going to produce a precipitate. So this is a type of reaction whereby they're doing a beaker or a conical flask and they draw a cross underneath, and they'd put a solution in there, react with another substance, and watch the solution go cloudy so that they then can no longer see the cross, and subsequently time how long that then takes for the cross to disappear. So in this type of experiment, which is the dependent variable, this is the one that you usually measure as a result of you changing another variable in that experiment. So the person in this experiment is measuring the time taken for this reaction. And so in this one, it is the time taken for the reaction to go cloudy that depends on the independent variable, which is the one that you have deliberately attempted to change. And in this situation, the student was attempting to measure the rate of reaction by changing the temperature of the reaction during the course of their experiment. So if they're changing the temperature and subsequently measuring the time, what are they going to have to control? Basically everything. Everything else. They're going to have to control the depth of the solution here. So if they've got a thicker solution, for example, then the time taken will vary depending on how much solution you're looking through. They're going to have to keep in considering all of the concentrations of any of the substances that they're using, so they're all going to have to be taken into account. Basically everything other than temperature is going to have to be controlled. Now, in doing that experiment, you're measuring how long it takes for a solution to go cloudy. That's a person looking down a beaker, looking into a substance to determine when they feel it has gone cloudy and they can no longer see the cross. In comparison, if you're taking the volume of a gas and literally just measuring that and recording numerical values, which of those is going to give you the more accurate result? Well, because measuring something going cloudy is down to personal opinion in some cases, but using the volume of gas is going to allow you more numerical and more empirical values to be produced, then the volume of gas is likely to give you more reliable, more accurate data as a result.